Good morning, ladies and gents. This is week number 10 of our online learning. And if all goes well, you should be here at some point this week. So some of these lessons, I'm going to record lessons for this whole week, but some of these lessons I might play in the classroom, which is going to be a bit weird. Anyway, that's quite exciting though. Quite exciting. Where's my black pen? Anyway, so we are looking at statistics. We're still within statistics, which is pretty easy, if maybe a little bit boring. Okay, that's just my opinion. And we're going to learn about something called a 5-number summary. It's nothing much new. It's just collecting stuff that we already know and maybe drawing it in a cool way. Okay. So I've got data, a bunch of data, 1, 2, 2, 2, 3, all kind of numbers from 1 to 10. It could be, I don't know, the number of cupcakes sold in different days, or number of different kind of cupcakes sold. I don't know, whatever, bunch of numbers. Now, what we learn is that we have 3 kinds of means, or 3 kind of averages. The first one is what we normally call average, which is already the mean, where we add them all up, divide by the number of values. The other one is the mode, the one that repeats itself. And then you've got the median. Okay? The median is the middle number. Okay? So half of the people got above the median and half the people got below the median. Okay? So let's try and find out that median. Okay? So I know I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 values. And rather than just go from the side and left and cross, let's use that formula. Okay, we know it's going to be 17 plus 1 divided by 2, meaning it's going to be the 9th value. Okay, so I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9. So that should be Q1, Q2 we call it. Okay, so I'm going to erase this now because I don't really need it, and I can see that 4 is my median. Okay, let's just check that. I've got 1, 2, 3, 4, 5, 6, 7, 8 before it. 1, 2, 3, 4, 5, 6, 7, 8 after it. So it is the median. Now we also said that we can continue and find another median for the bottom half, which we will call Q1. It's the lower quartile range. And the median for the upper group, and that will be Q3. So now we've got 1, 2, 3, 4, 5, 6, 7, 8. Okay? So we're going to do 8 plus 1 divided by 2, which is 4.5. That means we're going to look between the 4th and the 5th value within the second group. And remembering, we're not counting that median. It's out. So 1, 2, 3, 4. And this is the 5th. So it's going to be between 2 and 3. So in other words, it's going to be 2, 5. I just did 2 plus 3 divided by 2. Okay? So this is Q1. Okay? Sometimes it lands on a number Q, sometimes it lands between 2 numbers. Right, and the same thing here I'm going to do also. It's between the 4th and the 5th, so it's between the 8th and the 9th, that's Q3. That's exactly the same thing, okay? I've got 8 here, so 8 plus 1 divided by 2 is 4.5. So the value is going to be 8.5. Okay? So far, so good. We didn't really change anything. Sorry about the lights gone. I think you can still, let me just pause and try and get that, so I'm not going to have a shadow. Whoops, half of my face. Okay, right, so back in business, we've got the lights, and I also magicked the little number line. Because what we're going to do now, we're going to put those 3 numbers plus 2 more numbers, that's the 5-number summary, on in a picture to represent what is happening here. And this picture is called Box and Whiskers, which is quite cool. Box, whiskers, like what the cat has, okay, whiskers. Okay, I've got whiskers as well. Right, what does that mean? Let's have a look for the minimum number. We didn't really talk, you know what minimum number, okay? We didn't mention it here, but the minimum number is 1. Okay, so we're going to put a little point, maybe we'll do it with another color. Green, okay? So minimum number is 1. What's the maximum number? No problem, 10. So we're going to put a point there. Okay. Now, let's find out what is, let's have a look at the median. Okay. The median is 4, so I'm going to put a line, okay, I have to do a line for the median. And then we're going to do another line for Q1. Okay, so 2.5 is between 2 and 3, we're going to put another line. And another line for Q3, 8.5. Okay, so I've got 5 numbers here all together. I've got the minimum. Let's use a different color for that one. Okay, I've got the minimum. I've got the maximum. I've got Q1, Q2, and Q3. Okay, 5 number summaries. Okay, with these 5 numbers, you're kind of giving an idea what's the distribution of the values. Okay, now we just got to connect a few lines. Okay, so we're going to make a box out of Q1 to Q3. So that's the box. And then we're going to connect the dots to the boxes. And that's the whiskers. Okay? We've got the box and we've got the whiskers. And by drawing this, you're giving an idea of what set of values you've got. You can see the minimum and the maximum. And then you can see where the median lies. And you can see what Q1 and Q3. Now, what is the idea of Q1 and Q3? Q1 and Q3, okay, this difference between Q1 and Q3 is where most of the people lies. Most of the value lies. Because Q1 is, let's put it this way, 75% of the people have more than Q1. Okay? And 75% or less than Q3, 70% of the values are less than Q3. So the numbers of between Q1 and Q3, if you think about it, is half the data. Half the data lies between Q1 and Q3. Half the middle data is between Q1 and Q3. So it gives you an idea where most values, where the average kind of lies. Okay? Now I've done before I started the lesson, I calculated the mean. And the mean came up as 5.47. So 5.47 is, I just want to draw it like they draw it, okay? So the 5.47 is going to be here. No, so a little bit below that. Okay, this is where the mean is. Okay? Now, normally we don't put the mean in there, so because it's a 5-point summary, so it's just minimum, Q1, Q2, Q3, maximum. But sometimes you're asked to show where the mean is. So put it above. Now you can see the mean is larger, okay? The mean, in this case, is larger than the median. In this case, we call it positively skewed. I want to see that. Yes, I spelled it correctly. So it's positively skewed data, or the data is positively skewed data. Okay? Plus, for me, positive. Now, if the mean is smaller than the median, in this case it wasn't, it was actually larger, but if it was smaller, let's say the mean was somewhere here, we call it, you guessed right, negatively skewed data. Negatively skewed data. If you've got a situation where the mean is exactly equal to the median, where the mean falls exactly where the median is, then we call it symmetrical data. Now, at this point, you really don't need to understand why we call it like that. Okay? You don't need to understand that. But in grade 12, it will be a bit more important. Even then, it's not a big deal. But, I like to kind of explain that to you. What does it mean that the mean is larger than median? Okay? It means that we have quite a few high values here. 8s, the 9, lots of 10. So, we've got quite a few of them here. So that skews the mean. It pushes the mean higher than the median. Okay? Think about a class. Let's say in a class. And everyone, you guys are all getting a result. Some people get 50%. Some people get 60%. Some 40%. Okay? This is the majority of the people. Then let's say a couple of girls, or a boy and a girl. I don't want to say names, all right? So let's say 2 or 3 people suddenly get 100%. Let's say it happens. Now, what will that do to the mean? It will shift it to the right. It will make the mean larger. But the median is still going to be low because, most people didn't get 100%. But just 2 or 3 people who get 100% can change the mean by quite a bit. So when we have these extra people getting really high marks, it positively skews the data. The mean sounds like, the mean now is like 70% because of those guys who got 100%, while most people just got 50, 60%. Does that make sense? Okay? Where if, let's say, the other way, let's say we have 2, 3, like, again, most people go 40, 50%, and then a couple of people go 0. Okay? Now, that's going to shift the mean to the left. So the mean will be like 30%, whilst most people go above 40%. Okay? So that will be when we say the data is negatively skewed. If the mean is exactly equal to the what do you call it, the median, that means there were no outliers. Nobody got really high mark compared to the rest or low mark compared to the rest. So the mean really represents the median. Okay? Right, I'll just pause here for a second. Okay, I'm not going to draw it, but I want you just to pause me now and just look at page 236K. Okay, I will put that question for you for your work. I just want to run through it. You've got Class A, Class B. You've got two different box and whiskers. You can look at that. Pause me now and just look there. Describe the feature and the scores are the same for both classes. So I don't mind doing that with you. There's certain things that are definitely the same. So they both have the same median, which is 80. They both have the same maximum, which is 96. Now, in 2, it says, the head of the department considered the median of each class and reports that there is no significant difference in performance between them. Is this conclusion valid? Support your answer with reason. So, if you're just looking at the median, then yeah, they both have 80. But when you look at that, do you think Class A and Class B are the same? Definitely not. I mean, and you need to give an reasoning why they're not the same. So here we go. I'm giving you the answers. Okay, you can see Class A, the minimum was way lower. The minimum was 30. In Class B, the minimum was 66. Okay, it's a massive difference. Okay, then you can talk about Q1 and Q3. Okay, I'll let you do that. They're not the same. All right. So that's it, guys. I'll see you in the next lesson.